All right, so this is your electric field lab setup. You've got your tray of water with a little bit of salt in it. You have 2 washers. I think your lab says hex nuts. It doesn't really matter as long as they conduct. You've got your black lead is typically your positive one, or negative. So black is negative. It's going to go, you have a lead going into the battery holder, and you have a lead going into the multimeter. It's a really long lead. All right, so you have 2 things hooked up to this end. And then on this end, you have your red lead, which will go into the positive side of your battery. Out of your positive side of your multimeter, you've got another lead that is hooked up, oops, to another washer. Let's put it back on there. There, to another washer. All right, so those are your setups. I think there's a little bit better picture in your lab of the whole thing. Having trouble getting the whole thing in my view there. Can you see that? Looks like that. All right, try this again. There we go. So for our data, when you use your multimeter, we have a 1.5 volt battery. You want the setting on your multimeter to be at least larger than the battery that you're using. So this is a DC volt. This is a DC current from your battery. So we can turn this on. This is 1,000 volts, 200 volts, 22, and then 200 millivolts. Obviously 200 millivolts is a lot smaller than 1.5, but 2 is slightly larger than 1.5. This is just the precision that you can measure with your multimeter. So the first thing that you're going to do is hook up your battery. And what you will probably notice right away, there we go, is there's going to be some bubbles over here on this negative side. You're going to start seeing a reaction as that current goes through. That's okay. All right, so you're going to take your lead. So this is your lead, and you're going to touch it to the negative end. Your negative end should have a 0 reading. So when we touch our lead to our positive side, this is a 1.5 volt battery, and I'm getting a reading of about 1.1. It bounces back and forth. Again, I cannot hold still to save my life today. But it should be pretty close. So basically that just tells me my battery is not a brand new battery. So we could use that as a 1.1 data reading. So on a new piece of graph paper, this one's going to get messy. There's no way to avoid it. So on a new piece of graph paper, you're going to mark, I'm going to show you here. So on your graph paper, you're going to mark, this is a positive end, this is a negative end, and the voltages that you got. So I had a, what did I have? I can't remember. I had 0 volts over here. Okay, so do we have 1.1 over here, right? Yeah, okay, I can remember. So now we have 1.1 volts here. So on another piece of paper, that's what we're gonna do. So this is our graph. So you can really, that's why we have this graph paper underneath, so we can really see where those numbers are and add that data. So what we're gonna do is we're gonna take our washer, and so here's our 0 point. If we move it over, I don't know, like 3, if we go straight across 3 blocks, we get a reading of 0.96. So that's what you're going to put here. If you go over another 3 blocks, you get a reading of 0.84, and that's going to be your data point. Okay, so that's what you're going to do, is you're going to graph this area. It doesn't have to be every single little block, but you want a good representation. So you don't want to just go straight across from here to there. You want to go over and up and around and get some really good data points. You should be able to see those equipotential lines as you go through. So let's just say, so here's 9.8. This is another way to do it. You find the other spot where you're 9.8. Where is that on your graph? 9.8. Okay, so you can graph it that way as well. So you want several different directions, several different data points all around both of your ends.